In this video, we're going to take derivatives using a variety of rules, ranging from product rule to exponential rule, all the way up through the rule for arctan and natural log, using quotient and product and chain rule, depending on what we need. So let's talk through a couple of these. So our first function here, f of x, prime of x, is, notice what we have here going on. We have two separate products. So we're going to use the product rule twice separately, and let me separate those product rules by a bracket. So first product rule, I'm going to leave x cubed alone times the derivative of arctan. The derivative of arctan is 1 over 1 plus x squared. Plus, now I'm going to leave arctan alone times the derivative of x cubed, which is 3x squared. And my first part of the product rule is done, or my first product rule is done, but now I've got a second one for this second part. Now, there's no simplifying I can do for the product of e and ln. It's only on composition because they're inverses, so there's nothing tricky here. It's just a product rule. So I'm going to hold e to the x constant times the derivative of natural log, which is 1 over x, plus ln of x times the derivative of e to the x, which is e to the x. And this one is done. There's not a lot of simplifying we could do. We could pull out the x squared in this first product if we wanted, and the e to the x in the second, but there's not going to be too much else we can do. Okay, let's go on to the next one. P of t equals 2 to the t times arcsine of t. This is an exponential function, so it's going to require an exponential rule, and its exponent is more than just t, so it's also going to require a chain rule. So first off, the derivative of the outside function is an exponential. The inside function here is the exponent. So exponentials always have themselves in their derivative, t arcsine of t times the natural log of 2, because the base was something other than e. Now times the derivative, and I'll do this in a couple steps, of the inside function, which is the exponent, t times arcsine of t. This derivative is going to require a product rule. So let's see how that plays out. Again, there probably won't be much simplifying we can do, but we can certainly take the derivative. It's good practice on our derivative rules. So here's the part that was already done. Now here we're going to have a chain rule. A product rule. So it's t times the derivative of arcsine of t, which is 1 over the square root of 1 minus t squared, plus, now I'm going to hold the arcsine of t constant, times the derivative of t, which is just 1. There really isn't any simplifying we can do on this one, so we're just going to go ahead and leave it as is. Last one I want to look at here is c. And there's quite a bit going on in c, as you can see. It's going to be a composition within a composition. So first thing we have to identify is what is the outside function first, and the major outside function and the major inside. So this inside the parentheses is my inside function. My outside is this being raised to the 27th power. So when I go to calculate h prime of z, first thing I'm going to do is I'm going to bring that power down in front. 27, I'm going to leave the inside alone. Arcsine of 5z plus arctan of 4 minus z, and then I'm going to decrease the power by 1, times the derivative with respect to z of the inside. So arcsine of 5z, which is going to require a chain rule, plus arctan of 4 minus z, which will also require a chain rule. So let's see what we get here. So h prime, this part's going to stay the same, 27. This part is already done. We've already taken the derivative here, so it's going to be the same no matter how many more chain rules, power rules, product rules we have to take. And that's important as you're learning your derivative rules to decide what's done and what still needs to be done. this needs to be done. Each of these need to be done. So first off, let's do the first one, derivative of arcsine. Now this is an arcsine of a composition. So what you got to realize is we did an arcsine earlier, but that was just arcsine of t. When it's more than t, that has to be squared. So 1 minus 5z, the quantity squared. And that's going to be getting multiplied by the derivative of the inside, which is 5z. And we'll do that in the next step. We should put this in parentheses. This next thing is going to be real similar. Now it's 1 over 1 plus 4 minus z, that quantity squared, times the derivative with respect to z of 4 minus z. And we'll end our parentheses out there. Okay, one more step is to take all those derivatives. We have 2 more derivatives still to take. Now this first part is all the same, 27 arcsine of 5z plus arctan of 4 minus z. I'm missing a set of parentheses up on this one, to the 26th times. Derivative of 5c is just 5, so I'm going to put the 5 on top. Square root of 1 minus 5z squared, plus the derivative of 4 minus z is just a negative 1, so negative 1 over 1 plus the quantity 4 minus z squared. And again, not much simplifying we can do, but we do have our derivative.